We got a lot to get to, so we're going to go ahead and get started. I don't know where my co-speaker is. He's coming. He'll be here. Oh, good. It's like standing outside a restaurant and like trying to get people to come in. Like, no, really, the food's amazing. That's right. Like one of those inflatable things, like standing out. All right, we're all a little punchy this morning. I don't think many people got much sleep last night. I'm Jordan Liggitt. This is DIMS. We work a lot on Kubernetes dependencies, and we're here to talk about them. So let's talk about dependencies. The systems that we build are not isolated, right? They exist in a world that has to integrate with other systems, and that can be really powerful, but it also means we depend on things that aren't entirely in our control. And so when you depend on something else, any problem anywhere in your dependencies becomes your problem as well. But enough about the flight system this weekend. Let's talk about software dependencies. Your projects probably start small, right? You write every line of code yourself. It's thoughtful, it's careful. It's a beautiful little jewel. If you need a new feature, but when you need a feature, maybe you don't want to re-implement it from scratch. You're like, oh, there's a library that does this. Let me go find that. So you go find a library, you do due diligence, now you have a dependency. That's great. Maybe it's a good dependency. Maybe this happens a few more times, and everything's fine. But then maybe you get less picky about vetting your dependencies. You have to pull in something quick to get a feature in, or maybe one of your existing dependencies sort of goes off the rails and starts degrading in some way. And before you know it, your careful little bonsai tree has turned into a dependency bonfire. So now you're just in damage control mode, right? You're trying to keep the fire burning low enough to not spread. And so let's talk about Kubernetes dependencies. Kubernetes has currently over 250 dependencies and over 1 million lines of vendored code. And believe it or not, this is a dramatic improvement from where we were a few years ago. So we have a lot of experience tending a dependency bonfire and wrestling it back into a bonsai. So we wanted to share some things that we learned along the way. So here's what we're going to talk about. We have a lot to cover, so let's get started. First up, reviewing dependencies effectively. So we're all probably familiar with the pull request that just says, like, it's like a one-line change in a Go mod file. It's like, oh, bump a dependency. It's like, that's a small PR. How bad could it be? Or maybe one that adds like a one-line use of a utility function in some dependencies. It's like, oh, we need to pull this in. This library already does this. Let's just use this. So these can appear small, but how do we review these effectively? The first step is to get visibility to what the change actually is. So you can't review or reason about what you can't see. So you have to understand what a change is going to do to your dependency tree. And we have a tool that we use. I had examples. So for example, say you have an app and you just need like a little tuple to store like a group version kind. Kubernetes has a type for that. What if you just used that type? If you looked at that, how would you know what that's going to pull into your dependency graph? So we have a tool called depstat that you can run, and it will tell you what are all the things you're depending on. GoMod graph will sort of do that, but it's actually really noisy and unhelpful in some ways, and so depstat sort of cleans that up and looks at that information for you. If you run it before and after a pull request, you can see, like, what's the diff? What does this do? So let's run that.
So just before we brought in depstats, the thing that we were trying to do was, we made a conscious decision, right, at some point saying, we're going to store the vendor tree in Kubernetes itself. So it's easier when somebody submits a PR, they have to update the vendor tree. So we know the diff between. Like typically, you've seen so many projects where they just update the mod file, and they don't store the vendor tree in there, so you don't know what is coming. Like, you'll make a small change in the Go mod file, and like you assume that everything is fine, but you don't really look at the actual diff that you're bringing in. So, we made a conscious decision for that first, right? Like that was one of the decisions. At least, there was a point in time where we said we could have taken the decision saying, hey, get rid of the vendor tree, but we still decided to keep that. So once we did that, then the next step was the depstats was the first tool that we added, just because it was hard to understand all the changes that were happening and how many files got changed and things like that. So we added dev stats there, and it was like a GSOC, LFX mentorship person that added this dev stat for us.
Yeah, so let's run dep stats just on that one-line change. Well, one line. Now we have 50 dependencies. Maybe you didn't expect that. OK, so that's in our graph, but surely we're not actually using code from all of those things. And that actually connects to what Dims just was talking about. How do you know what code you're actually using, right? Like, you have dependencies to those, but we only use one package, one type. How bad could it be? When you vendor, you actually see, here's the packages you need to build the things you're referencing. And so that lets you basically do code review of your dependencies, which is super tedious and kind of sucks, but you're responsible for what gets built into the binaries you ship. So it's good to know what's in the binaries you ship. All right, so let's vendor based on that one line. Oh, look, we're pulling in an unmaintained protobuf library. You probably didn't expect that. Actually, this is something we're fixing in 135, which we'll talk about later. But in the meantime, if you had done that and known that pulling in that type was making you link in this library, maybe you would rethink that. Maybe it's worth it to you, but you want to make informed decisions, right? The value you're getting from it versus the cost that you're taking on. So vendoring gives you visibility and lets you see what you're actually linking in. Here's another example. Unstructured. You're decoding into an unstructured object, and there's a helper function that lets you traverse it and pull out some keys. It's just a helper function. How bad could it be? Let's go mod vendor again. This one's even worse, actually. I tried to get it all. I couldn't even get it in. This goes on for like 5 more pages. So go mod vendor. It does blow up your source tree a little bit, but it gives you so much visibility and makes it visible. So when there's an update, you know what is changing. There's a lot of new stuff coming in. There's a lot of existing stuff I depend on changing. All right. What are things we look for as we're doing those code reviews? We probably can't reasonably do super detailed code reviews, but there are some high-level things we can look for. One thing is to look for init functions. This is code in your dependencies that will run even when you don't call it. And so that's a special thing to pay attention for. As a tip, you can add .diff onto the end of any pull request URL and see like the full raw diff, and then just search for like func init. That's easy for like flattening out stuff if GitHub is struggling to show you a diff. So this is one specific thing we look for. Another thing we look for is compatibility breaks. So anything that's in your dependency that gets passed through to your users, so API surface, metrics, endpoints, types, function signatures, sometimes behaviors, anything that gets passed through to your users, look for breaks in compatibility. So that kind of means reading the release notes. If you're jumping 6 major versions of a thing, you probably need to go read the release notes from that thing to see if they announced breaking changes and think about whether that's going to get passed on to your users. And then the last key there to avoid needing to do manual reviews all the time is add your own tests for the surface area of your dependencies that you're relying on. So if they're exposing something and you depend on the behavior of it, add a test in your repo so that if they change their behavior in a breaking way, your test will notice. All right.
Just to set some context here, right? You get a lot of drive-by pull requests, right? Like people from all over the place, they want to fix a small thing or add a small feature, and like they don't know the history, they don't know the context, they don't know why we are using some dependencies, they don't know why we are not using some other dependencies and things like that. So we do have a special set of people who look at dependencies in depth, exactly like the way Jordan is talking about. So it's important for any project to build that muscle up if you're not doing that already, right? Like that was one of the lessons that we learned during this process. If you go back a few years, you will see all kinds of dependencies that were there in the tree, right? Especially because we were bringing in all the cloud providers. There were in-tree components and things like that. So it was a literal mess at that point in time. So over a period of time, we've gotten better. So
I wanted to talk really quickly about three areas of your project. So packages that are just used as library packages that other things depend on, like that's pretty normal. If those things make use of dependencies, those are going to get passed on. That's fine. But if you build binaries, if you have commands that build binaries out of your project, anything those binaries depend on will also get passed on to anyone that depends on that module. And so this was something that we saw in CAdvisor. CAdvisor had both a binary and a library, and Kubernetes depended on the library portions of it, but didn't actually run the binary part of it. And the binary linked in a lot of other things, so they could integrate with different container runtimes and different cloud providers, and Kubernetes didn't actually care about those aspects, but because it was all sort of smushed together into one module, we inherited all of the dependency graph complexity from the things the CAdvisor binary was using. And so we went upstream to the CAdvisor project, and I mean, it's people who also work on Kubernetes, it's us, and helped like figure out a way to carve out the binary portion of it, so that the dependencies that were only needed by the CAdvisor binary wouldn't have to get passed on to library consumers. So that's one strategy if you're trying to figure out how to sort of untangle things or firewall one set of dependencies from your libraries. Another aspect is test-only dependencies. So again, if you have Go tests and they're making use of dependencies and they live in the same module, those get inherited and passed on just like anything else. And so there's two implications there. One is we can't just ignore the health of a dependency because it's test-only, right? If it's unmaintained or it's incompatible with later versions of other things that we need to pull in for security reasons, like it really does impact the health of the project. So we can't just say, oh, it's test-only, it doesn't matter. But if there's something that's especially big or transitive, pulls in a lot of things, it may actually be worth isolating with its own Go module as well. So it's a strategy we can use. It works. There's a little bit of cost to it, but it's worth considering.
So the thing, if you let it in, is somebody will come later and say, hey, this dependency is already there. Why don't I just use it in my PR, right? Like, it's already there. It's already blessed. So there's that tendency as well. So like, by being more rigorous about it, you are essentially, saying no to it before.
And then the last category is things that we don't even really build, but just sort of use in scripts or code generation, or tools, we call them. Go 124 added a tool directive in the Go mod file to help track dependencies that were related to tooling. And a lot of people thought, oh, this is great. It's going to let me isolate my tool dependencies. It did not. All it did was, it's basically an annotation. It's like, why is this even in here? It still shows up as an indirect dependency. It still gets passed on to everyone downstream of you. So if you have a bunch of like random, like we have a spell checker in Kubernetes, I guess. We have our own like sub module that's just tools that isolates those, so that if there's an issue with one of those, it doesn't show up in a scanner for the top level module. If there's an incompatibility with one of those, it doesn't keep us from updating like the dependencies we build and ship with. All right, so we talked about problems we can encounter. I hinted at this with the CAdvisor thing. Our upstreams are not immutable, like immovable mountains that we just have to sit next to. I'm like, well, it's bad, but what are you going to do? We can actually go to our upstreams and improve them. Sometimes the problems they're passing on to us, they're not even aware of. Sometimes it's as simple as like going upstream and saying, hey, you added a test that pulls in this crazy thing and it's coming down to us as a dependency. Like, this is really difficult. Could you remove it or isolate it? Sometimes it's as simple as asking. Sometimes they will be amenable, pull requests welcome. If you will go do the work, they will accept it. but you kind of have to go do the work. And so we had a few examples. The C Advisor one was one I already mentioned, where we basically just made a separate module for their binary. DIMS also went upstream a bunch of times to Containerd, and we were pulling in like all of C Advisor. We were pulling in all of Containerd when all we needed was the API types.
So the fun story behind this is like it took the initial PR landed, and then it got reverted. And then it took almost a year to get to the point where, okay, yes, now we know it's a real problem because other people are also saying it, not just Kubernetes. And then finally, and like it was making their life more difficult. So it was yanked out of like 1.6, I think. But then finally, we ended up landing it later in 1. I don't know if it made it into 1.7, but definitely 2.0. And then we were able to use it at that point.
Other random things. Sometimes there will be things upstream that aren't being used by anybody. C Advisor had put this in for Kubernetes, and then we reworked how we did these metrics. And so they were like, we had it there for you. And we're like, well, we didn't want it. We weren't using it. I'm like, well, let's just delete it. That's nice when it happens. This was another case where there was a library that sort of mixed together a bunch of yes, mixed together a bunch of things, and Kubernetes only needed a tiny little slice of it, and they were very gracious to, with a lot of work, extract the slice that we needed as a library to its own thing. Yeah, they were heroic. So there's a lot of different strategy. This was the result of that. We dropped from 416 dependencies to 371. So it's pretty good. This was a long time ago, actually. Cobra, which is the framework a lot of tools use for like the command lines, had a similar thing where they had a binary command that was in the same repo as their like framework, and the binary command dependencies were just kind of running wild, pulling in Viper and I don't know, a bunch of other stuff. And so I helped extract that out, and they were amenable to doing that. So it's kind of a mix of identifying the problems, going upstream and like asking nicely or proposing a solution, and being willing to like put in some work upstream to make the solution happen. They were very nice. All right, this was the headline. Like, how did we drop 30% of our dependencies in 2025? So, Gen Proto. This was a mega library that basically had every protobuf type associated with any Google Cloud API. And it was like a mega library. They did some refactoring, and as part of their refactoring, they add dependencies from that back to like the core Google Cloud module, the client modules. Problem was, one of the types in this Gen Proto thing was like a generic RPC type, like super generic, used by everything. Like the whole Go ecosystem imports this package, basically. And so that transitive dependency, the whole Go ecosystem to this generic package now has transitive links to Google Cloud libraries. And it was a mess. It took us 3 years to unwind this. We went upstream to the Gen Proto folks and figured out how to carve their thing apart, and then grudgingly accepted an update into Kubernetes that bumped our dependencies from 277 up to 390. That was a bad day. But we only did this once we had a plan to dig ourselves out of it, right? We waited until we could see the light at the end of the tunnel, even though it was a long way away, before we took this on. And then from there, that was 2023. Then we isolated it, rippled it out to like every repo on GitHub that we could find. And then I opened this last year, but it just merged middle of this year when etcd finally updated, and we got back down to 247. So this was a 2 to 3 year journey. It requires patience. It requires perseverance. Don't be discouraged. We actually can make a difference. Yeah. All right. Patient, be pragmatic, be persistent. But we're going to hand it off here or the next one?
Next one.
Next one, OK. So say you've identified some dependencies that are problems, and you want to get rid of them. How do you do that? You can't just, like, as nice as it is to just delete stuff instantly, we can't always do that. So how do we do it effectively? We have this idea of ratcheting that we use a lot. We use it for validation in the API. We use it for dependencies. The idea is you identify a thing you don't want, and then you put something in place to keep it from getting worse, right? So no more new links to this thing we don't want. And then you start chipping away at the bad links, one by one by one by one. So in Kubernetes, we have a dependency verifier, and we have this JSON file. And it kind of follows the spec status split that we do in the API. So spec is how we want the world to be. Here are things we don't want. And so it's just a list of them and a reason for onlookers to follow.
Yeah, you really have to go look at this file. You will get a sense of like the history of why we did what we did, and like if you look at the diffs that are going in, there are pointers to the PRs and issues in everywhere on Earth, kind of thing. It's really something. Yeah.
And so then status is how the world is. And there's two aspects, right? One is, do we still have links to these things, just in our graph? And then the second is, do we actually still need to vendor them to build them? And so we track both of those things. And so anytime a new link to something we don't want shows up, we have a pre-submit that makes sure this is accurate. It'll yell at you and say, you're trying to add a new dependency to a thing we don't want. Like, don't do that. Sometimes, again, we're pragmatic. Sometimes we do need to take a link to a thing for a good reason. But this keeps it from happening accidentally, which is basically the default. The default is stuff gets worse and you don't even notice. And then anytime something improves and we drop one of those links, it notices and says, oh, great, we dropped a link. Delete this from this line. So we ratchet and like don't backslide.
We also have specific pinned versions above which you can't upgrade for certain things because either they are broken or like we don't know what is in there or we don't want to update. So we have that as well captured in this unwanted dependencies.
And the goal over time is to not have anything pinned, like to be able to consume the latest versions of everything, and to not have anything unwanted. Like we're always trying to get to that state. We'll probably never get completely there, but hopefully we're making progress. This is the pre-submit that like checks that to make sure everything is working the way we want. All right, now I'm going to hand it off.
Okay. So for the longest time, one of the issues that we had was, hey, the day you want to bring in, say, new OpenTelemetry or like Prometheus or some of the other projects. So the person would go there, update the GoMod file, bring in the vendor dependencies, and we would run the tests, and we'd say, boom, everything is broken, right? So by the time we understood that things were broken, it was like too late because like they had already made their releases and everybody was celebrating, but it doesn't work for us. Like, how do we get to know before it happens so we can like prevent this? We know our usage. We know what we use those dependencies for. So wouldn't it be easier if we get alerted? So that was one problem. The other problem that we had was updating Golang itself was a major pain in the ass, right? Because somebody had to update the Golang and like run it through all the CI/CD jobs that we had, and like you don't know what you were going to get, and things would break. And Jordan actually went up to the Golang folks, and we got agreement from them to have some toggles so we could have the older behavior when we updated to a newer Golang. But if we found some problems, we can actually switch on the older behavior so we could have some breathing room. just because Golang has a different release cycle than us. So we had that problem too. So we needed a bunch of things to understand. First, there is a problem, and the second is like as early as possible, so we could go back and engage with those teams upstream that we are using and tell them, hey, can we work with this? Can you come up with like a solution? Or can we guide us on what is the preferred solution for, that you would like us to do, kind of thing. So what we have today is we have a set of CI jobs. What they do is they pick up the latest from master branch, and they run go get -u against each of the dependencies. So at the end of the day, you will have a full set of dependencies with the latest versions of each of the vendor projects. And then we would run a series of tests against that version, those updated GoMod file, right? And updated vendor dependency. So this gives us a whole bunch of information about like, hey, Prometheus came up with a version yesterday. This morning, our CI broke. Right? This has happened more than once, not just Prometheus, but OpenTelemetry and other projects as well. So that gives us a sense of like, okay, we could go even further and say if we can go against the master or main of the different vendors, but that's just too much. We can't do that.
And it's way easier to go to a project like 24 hours after they released a tag and say, this tag broke something. Can you like undo it or fix it or whatever? Then if we discover it 6 to 12 to 18 months later, and they're like, well, we can't possibly undo that feature. We have people relying on it now.
Right, exactly. So we also have one similar for Golang where we build Golang from master branch. We don't wait for them to make a release. So we take the master Golang and then we run the test against them. So it's the same exact components, same exact thought process where to catch the things early. And like it's gotten to the point where it is extremely easy for us to update to newer Golang now these days than what we had to deal with a few years ago. So just as an example, you want to talk about this?
Yeah, in preparing the slides for this, I realized that, this job flagged something that broke a week ago. So it's broken right now. It's not something upstream changed from a pointer to a non-pointer, or vice versa. So like we will have to adjust to that, which in this case isn't a big deal. But it's nice to know that so that we can go ahead and plan for that adjustment. Like right after code freeze is done, we'll probably bump versions and go ahead and make that adjustment, just so there's no friction if we needed to pick up an update from head from this dependency.
Yeah, since we know we are on code freeze, this doesn't really hurt us right this moment, but it's going to hurt us when we get out of code freeze and we need to like figure out a plan for it. So tracking dependencies over time, we run a bunch of simple checks all the time. Depstat, we talked about. Also, you want to talk about this one?
Sure. So I told you we have 1 million lines of code, and this is better than it used to be. We're actually back to around where we were like 110-ish level in terms of like amount of vendored code, which is kind of amazing. So yeah, I mean, we have tools that check number of dependencies, how far away from latest releases of dependencies we are, how many lines of code we have, how many direct dependencies, transit dependencies, stuff like that. And again, it's just getting visibility of the problem. If you don't pay attention to it, you see just sort of steady growth, which is what you see on the left side of that graph. From whenever I started, 1.0, up through like 1.16, 1.19, it was just steady growth. And that wouldn't have changed if we hadn't made concerted efforts to start isolating and paring down. So a lot of that was cloud provider extraction, but some of it was like the Gen Proto stuff that we had to untangle.
So again, this goes not just dependencies are not by themselves the big thing, right? Like when people run 100 types of scanners against our code and everything in our ecosystem, right? Like if we get caught and there is either false positive or actual security fixes, CVEs that are open, then we get affected. So it's important for us to like make sure that we are always updated to the latest, and also we are, as few things as possible in our inventory that we really need. So we make sure that we don't have duplicates of things and things like that as well. So keep master branches updated, check vulnerability. We use go-vuln-check as well as SNCC and then also we go back and update our release branches. You want to talk about this one?
Yeah. So keeping master up to date so that the delta between what we're using on our development branches and the latest releases of projects is as small as possible. That's a good practice, but we only update our release branches when they're actually impacted by a security vulnerability. And we mean actually impacted, like we're using the package where the vulnerability was, not just that we depend on a version that had a vulnerability. And so that's where go-vuln-check is really helpful. Some scanners are very naive and just module level say, oh, that module version has a bug, but we're not even like vendoring or linking the package where the bug existed. So go-vuln-check is helpful for determining when you actually have an issue. So, whirlwind. We're here all week. Come talk to us. If you have questions about dependencies in your own projects, we're happy to share strategies. But hopefully, with some time and attention, we can get from our current bonfires back to happier bonsais. Thank you.